Today we're going to talk about lines of best fit, linear regression. This is used when we have data that when we plot does not form a line, but we want to represent the data as a line. So if we go through exercise 1, we're going to see exactly how we could do that. So exercise 1 says a biologist is studying the relationship between a tree's diameter and its height. So I just want to highlight those two. So here's your tree's diameter, the information, and the height would be given in that row. Okay, I just want to point out quickly that that is the exact same thing as if we had a table of values looking like this, okay? So it would be 2, 8, 310, that's the way it would look, so on and so forth. Okay, so next, let's look at what they want us to do. On the grid provided, create a scatter plot of the data. Use the diameter and the as the independent. So diameter, I think we had highlighted in green. So diameter is the independent, and the height is the dependent. Okay, so we can just label our graph because the diameter being the independent. They're telling you diameter is the x-axis and height is the y-axis. So we're going to label our graph diameter for the x-axis, and then we're going to go over to the y-axis. So let's just put a little y up here. I actually wrote a little x out there, you just can't see it. There it is. Now you can see it. Okay, so, and this is going to be our height. So H-E-I-G-H-T. Okay, so we have them labeled. Now what we have to do is determine our scale. So let's look at our table. Okay, our x's go 2, and the highest one is 8. So we can just label our table, by ones on the x-axis. So we're just going to start here, 1, 2, and so on. So go ahead and do that. Okay, so you have all your numbers on there, and now we look at the y-axis. Our y-axis, the highest number there is a 29. Well, let's look at the graph. We're not going to make it up 29, so we're going to have to go by 2. So this would be 2, this would be 4, 6, 8, 10, 12, and so on. Okay, so you can see you go up to 28, and then this would be 29. If you look at your table, your highest height was 29, so how convenient is that? So next thing we're going to do is we're going to plot these points. So the first one's 2, 8, the second one's 3, 10. We go to our table, go over 2, 8, 3, and then 10. I'll do one more with you. The next one's 4, 16, 4, 16. Okay, can you see how that's not going to create a line? One more. 5, 17. So that's 5, 16, 17. Okay, go ahead and plot the rest of those points, please. Okay, so I have plotted all my points. Make sure you've done the same, that they look something like mine. Okay, the next part says, draw a line of best fit through the data. As a guide, try to have as many points of data fall above the line as below the line. Okay, so here's what I would typically do. This is not an exact science. What I do is I start at my first point and I just bring the line up and see how it is I'm going to, okay, so how it is that I'm going to get this line. So I have, look at my data now, 1, 2, 3 above, and I have 2 below. If I just move it a little bit, 1, 2 above, 1, 2 below. So what you're going to be doing is taking your straight edge and just kind of figure out where you can count your data and see if you can get it so that there are two above and two below the straight edge. And then I just continue the line on like so. Okay, so let's see. What did I end up with here? I have a line. I have one, two above, two below. You know, I could move it around a little bit, but it's pretty good. It's not an exact science right now, so this is good enough. As long as your data has a couple of points above and a couple of points below, and I would even say, let me just see, if I move this here, I almost like it better because really you want the data, you want the line going through the data, through the middle of the data. Okay, so part C says write two ordered pairs that lie on your line. We're actually going to skip that part. And it says determine the equation of your linear function. We're going to do that, but we're not going to use the two ordered pairs. What I want to do is I want to use this line that we drew. Okay, so we're going to go up to this point here. That's our B value. Okay, so our B equals, now that's a 2. Remember, we went up by 2, so B equals 2. And from that point to the next point here that I can really see is up 2, 4, 6 over 2. So M equals up 6 over 2, which is equal to 3. So my equation of my line is going to be y equals 3x plus 2. Okay, so is that exactly the equation of the data? No, it's not, because our data does not fall into a line, but it's called the line of best fit. It's the best line we can come up with for the data. Okay, let's keep going here. Okay, so the next part here, E, says, oh, because we're skipping this guy. The next part, E, says using your linear function from part D, so it was y equals 3x plus 2. Estimate to the nearest foot the height of the tree given, sorry, I have to move this over, given that its diameter is 14 inches. So remember, height was y, so we're trying to find out y, and our height, which is x, is 14, so it's substitution. Oh, see, just like almost everything else we've done in here. So 3 times 14 is 42, plus 2 equals y. So according to this, our height of our tree should be 44 when the diameter is 14. Now let's just take a quick look back at the graph and see if that makes any sense at all. So it's 14 comma 44. Well, let's see. 14 would be here, and you see 44 is way up there. But if you kind of like estimate it up, you'd be able to see that it probably is going to fall somewhere around where this line would go if it was extended. So that's what we're trying to do, is we're trying to what's called extrapolate information from the data that we're given. So right here it says this type of calculation is called extrapolating. We're using the model, this is our model, to predict outside of our data set. So to go on and make a conjecture based on data that we've already plotted or come up with an equation or a model for. Okay, so that's the first one.